All right, we're starting a new chapter, and the chapter's focus is on circles. Uh, we're going to be in 10.1 talking about tangents to circles. And first, we're going to cover some vocabulary. A lot of this stuff should be review from 7th and 8th grade, but it's always good to make sure you know what you're talking about. A line that has endpoints on the circle and goes through the center of the circle is called a diameter. The radius is a line segment from the center of the circle and has one endpoint on the circle. And the circumference is the distance around the circle. So here this red line represents the circumference if you cut the circle here and laid it flat. Okay, so you know, that's an important concept, that the circumference is not, you know, it can be, it's a linear length. It's a line. Okay. Now, congruent circles are circles with the same radius. If they have the same radius, then they will be congruent to each other. And a secant is a line that intersects the circle in two places, where a tangent is a line that intersects a circle in one place. A chord is a line segment that has endpoints on the circle. Now, a chord could also be a diameter if it went through the center of the circle. Tangent circles. These two circles are internally tangent. There's a tangent line here. This tangent would be external, but the circles are internally tangent. And these circles, I guess I'm going to even erase this line. We'll talk about the external tangent of a line here in a bit. But these circles, both of these circles intersect in just one place. That's why they're tangent to each other. And the circle's inside, so it's internally. Circles that are outside, external tangent. Circles that share the same center, okay? Circles that have the same center are what we call concentric circles. Like the Target logo is made up of concentric circles. Now talking about tangents. This line is a tangent line because it intersects both this circle in one spot, intersects this circle in one spot. And since it's a tangent to both circles, it's a common tangent. And since this line, the tangent line goes between the two circles, this common tangent is, this tangent line is, goes between the two circles, so it's an internal tangent, where these common tangents are external. They go outside of the center of the circles. They do not go between. Example 1, give the center and radius of each circle. So we talk about the first circle. This is the symbol for circle, circle A. Center is at -3, 2, and the radius. So when you find your radius, you want to go from the center to a side and over straight down or straight left. Usually those are the easiest to find. So the radius would be 2 units. Circle B, the center is at 1, 2, the radius of 2. describe the intersection of two circles. So these circles are externally tangent. Because they intersect at one spot, and the circles are on the outside of each other. And describe all common tangents. There's going to be two tangent lines, 1, 2, that are external common tangents, and there would be one common tangent that would be an internal common tangent. A lot of times we like to just use equations. This would be the equation x equals -1. This is the equation y equals 4 and y equals 0. Those would be the equations of the tangent lines. That's a great way to describe them, right? Y values are all 0 all the way along here. Your x values are all -1 up and down here. First theorem in chapter 10, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. So the place where the line and circle intersect is the point of tangency, so the line is going to be perpendicular to the radius. And theorem 10.2 is just going to be the converse. If you have a line that is perpendicular to the radius at its endpoint, at the radius's endpoint, then this line will be a tangent to that circle. So, is EC a tangent to circle D? So we want to know, is that a right angle? Well, to do this, you get to use that converse of the Pythagorean theorem. We get to check to see if this is a right angle. So this is our potential hypotenuse, and here's my radius. And we have these two measurements. So we're going to take 11 squared and add it to 43 squared and see, does that equal 45 squared? Squaring that, that's 121. And get the calculator out and take 43 squared, 1849, and 45 squared, 2025. And we ask ourselves, are these things equal? Looking at just the back two digits, if I had 21 to 49, I'm going to get 70. So I know these aren't going to be equal, so this is not a right triangle. If it's not a right triangle, well, what do we know then? We know if this is not a right triangle that these lines aren't perpendicular, right? They'd have to make a right angle to be perpendicular. This is an interesting problem. If you're standing 14 feet from a water tower, so we have this picture, and if you're 14 feet from the water tower, you're going to be kind of measuring that at the straight distance, the shortest distance to the water tower. We're saying that's 14 feet. The distance from you to a point of tangency, if this is a point of tangency, this means that's a right angle, is 28 feet. What is the radius of the water tower? We'll call this X or R, whatever you want. But we're looking for this value. So we can actually use the Pythagorean theorem, but we're going to call this distance 14 plus X. From here, we get to say X squared plus 28 squared equals the hypotenuse 14 plus X quantity squared. So X squared plus 28 squared, and when you multiply this out, remember to FOIL, you get 196, that's 14 squared, plus 2 times this, that's 28, x plus x squared. And we can subtract x squared from both sides. That cancels. This is squared here. So 28 squared, 784 minus the 196. Oops, that's the buttons in the wrong order. 28 squared minus 196 is 588. So I subtracted 196 from both sides, and I got 588 equals 28x. So I need to take that answer and divide it by 28. X equals 21. So the radius of this circle is 21 feet. The next theorem, if two segments from the same exterior point are tangent to the circle, intersects the circle in one spot, then this segment is congruent to that segment. So in this case, we know this is a external or a tangent line because it's perpendicular, and we're assuming that it intersects the circle in one spot. So now we know that x squared minus 4, since these segments are congruent, has to equal 21. If I add 4 to both sides, I get x squared equals 25. And when I take the square root, I get x equals plus 4 minus 5. Okay, this is something that most people will forget. And in this case, we're not talking, x is not a length, it's a variable. This whole thing is the length. But since it's just a variable, we have to include that in our answer. We could technically put negative 5 in for x, and we'd still come out with a positive length. So there's 2 answers on that one. Here's your homework assignment. I hope you guys bring some questions about this 10.1, and have a good section, a good chapter.